Welcome back to topic 45 for Algebra 2, Properties of Radicals and Solving Radical Equations. In part 2, we're going to learn how to add and subtract radical expressions, as well as multiply and divide them. So, when adding and subtracting radical expressions, we want to think about like radicals, similar to kind of like terms. So in order to combine these radicals, they have to have the same index and the same radicand. Now we might not see that in an expression right off the bat, so we might need to further evaluate and further simplify our radicals. Here's an example. We have the square root of 20 minus the cube root of 16 plus the cube root of 250 minus the square root of 5. What I want us to do first is to group radical terms with like indices. Now indices is the plural of index. You might also see indexes. That's also commonly used. So here we have the square root of 20 and minus the square root of 5. So here they have the common index of 2. Whereas negative cube root of 16 and positive cube root of 250 both have that cube root as their index. So if I regroup them, we have 20 minus the square root of 5. I should say square root of 20 minus the square root of 5. And notice how I kept the respective sign that's in front of that term with it. That's allowing us to do it because addition is commutative. We can flip the order as long as we just keep that sign that's in front of it along with that term. Then minus the cube root of 16 and plus the cube root of 250. Okay, how can we break this down even further? So the square root of 20 and the square root of 5. These both don't have the same radicand, but we can simplify. Here's again where I want you to think about the factors, where we can easily take the root of that factor. So square root of 20 can be broken down to be the square root of 4 times the square root of 5. Then we're going to minus the square root of 5. Now similarly, if we have the cube root of 16, that can be broken down to be the cube root of 8 times the cube root of 2. Moving along to the cube root of 250, we know that we can simplify this cube root of 8 eventually. So in order to have the like radicand, we're going to look to the other factor pair of 2 that goes with 250. So 250 divided by 2 gets us 125. Kind of smushed that in there, but okay, let's go through and simplify. So the square root of 4 times the square root of 5 gives us, 2 root 5 minus root 5. That term is already simplified. The cube root of 8 gives us minus 2, cube root of 2. The cube root of 125 gives us 5 times the cube root of 2. So here what we did was we simplified each radical term. Now that we notice that we have the like radicals with the same index and the same radicand, what we're going to do is we're going to factor out the radicals with the inverse of the distributive property. So we have this 2 here, and really in front of this negative root 5 is a 1. So I can factor this out to be 2 minus 1 times root 5. Then we also have a negative 2 here and a positive 5 here. So this can factor to be, we're adding, a negative 2 plus 5 times the cube root of 2. Now going back to the blue, 2 minus 1 simplifies to 1, so 1 times root 5. Negative 2 plus 5 gives us positive 3, so positive 3 times the cube root of 2. Now if we have a coefficient of 1, it's common not to write it, so our final answer will be the square root of 5 plus 3 times the cube root of 2. Let's go into some more examples. Here we have 4 times the cube root of 54 minus 2 times the cube root of 16. Here we both have the like indexes, so we don't need to regroup anything together. But we can try to simplify and think about the factors of our respective radicands. Here we have the 4 on the outside. Now the cube root of 54, I can break that down to be 27 times 2, specifically the cube root of 27 times 2. We can also leave our coefficient of 2 out front, and the cube root of 16 is the same thing as the cube root of 8 times 2. Further breaking this apart, we have 4 times the cube root of 27 times the cube root of 2 minus 2 times the cube root of 8 times the cube root of 2. Now I can simplify. 4, now the cube root of 27 is 3, times the cube root of 2 minus 2, the cube root of 8 is 2, and then we have the cube root of 2. Notice here how we both have the cube root of 2. So we have like radicals now, same index and also same radicand. I can simplify my coefficients out front. 4 times 3 gives us 12 times the cube root of 2, and 2 times 2 gives us 4 times the cube root of 2. Now I can factor out these coefficients of 12 and negative 4 to get 12 minus 4 times the cube root of 2, which simplifies to 8 times the cube root of 2. Moving on to the next example here, we have 7 times the fifth root of 12 minus the fifth root of 12. Now, can we reduce the fifth root of 12 at all? No, but notice how we're already set up with like radicals. They have the same index of 5 and the same radicand of 12. Now in front of this second term, negative fifth root of 12, there's really a 1 here. So we can go right about and do 7 minus 1, those coefficients, times the fifth root of 12. This gives us 6 times the fifth root of 12. Now we're all set here because we can't simplify the radical any further. Moving on to multiplying and dividing. So here we don't have like radicals, but for multiplying and dividing, the radicands do not need to match, just the indexes. So we just want to deal with the same root. With our first example, we have negative 7 times the square root of 2 times the square root of 3. So here our indexes are both 2. Just square root is so commonly written that we don't include the index of 2. This gives us negative 7 times the square root of 2 times 3, which simplifies to negative 7 times the square root of 6. With the next example, we have the square root of 20 divided by the square root of 5. Here again, the indexes also match. In this case, they're also an index of 2. Now, how would we simplify this? Again, we can think about our factors of the radicand. what are the factors of 20? We can break that down to be the square root of 4 times the square root of 5 divided by the square root of 5. Now here, these 5's reduce to 1. So all we're left with is the square root of 4. Now this simplifies to just positive 2 because this 4 is referring to the principal root. And when we're dealing with the principal root, we have a positive number as our answer. It's a little bit different if we were to have, well, x squared gives us 4. Here, there are two possible values for x. X could equal positive 2 or x could equal negative 2. But when we're going backwards and we want to think about the square root of 4, that just gives us a positive 2. Moving on to our next example, sometimes when we're asked to multiply, we have binomials. So what is the reduced form of each product? What we're going to do here in our first example is use the distributive property. So the cube root of 7 times 2 and the cube root of 7 times negative the cube root of 49. With our answer, we have 2 times the cube root of 7 minus the cube root of 7 times the cube root of 49. Here again, the indexes match. 2 times the cube root of 7, we can't simplify that any further, so we'll just leave it. And we can multiply 7 times 49 because they have the same index of 3. Now 7 times 49 gives us 343. Now what is the cube root of 343? What number times itself again gets us 343? Our final answer is 2 times the cube root of 7 minus 7. Now here we can't simplify it any further because we don't have a like radical with the same index and radicand, so we're all set. In this next example here, we have 2x minus the square root of 3 times 2x minus the square root of 3. Or this can be written as 2x minus the square root of 3 squared because we see the same quantity twice. What we're going to do here is we're going to multiply. Now, if you know the acronym FOIL, we can FOIL here using the first, outside, inside, last terms. I'm going to use the horizontal method, which is kind of a general term or general way of doing foiling. Foiling only works specifically with a binomial times a binomial. 2x times 2x gives us 4x squared. 2x times negative square root of 3 is minus 2x times the square root of 3. Negative square root of 3 times 2x is negative 2x square root of 3. And negative square root of 3 times negative square root of 3 is a positive square root of 3 times 3. Now 4x squared minus, here we have like terms, same radical, or they're like radicals. We have the same index and the same radicand. So this combines to be minus 4x square root of 3. And then 3 times 3 is 9, so the square root of 9. This simplifies to 4x squared minus 4x square root of 3 plus 3. Now I want to show you a quick trick, especially with this last part. When we had negative square root of 3 times negative square root of 3, we know that a negative times a negative is a positive. So we're going to end up with a positive value. And what we did here was this is negative, square root of 3 squared. Because my index here is 2, again, if the index matches the exponent, they cancel and what we're going to be left with is whatever the radicand is, so just 3. So that's a way, if you recognize that early on, where we got that 3 from. That was part 2 of topic 45 for properties of radicals and solving radical equations. Thank you for watching.